Space exploration is one of humanity's greatest achievements, a pursuit that pushes the boundaries of technology and knowledge. Yet, as we reach for the stars, we encounter significant challenges that are often overlooked. These include not only the tangible financial and environmental impacts, but also broader ethical and societal implications. Exploring these disadvantages provides a well-rounded view of the costs involved in this quest, helping us understand the potential consequences for Earth and its inhabitants. Each mission to space costs billions, and as our ambitions grow, so do the budgets. For example, NASA's Artemis program, aiming to return humans to the moon, is expected to reach upwards of $90 billion by the end of the decade. The costs of establishing lunar colonies or planning Mars missions could be even more astronomical, potentially diverting funds from urgent social issues back on Earth. The financial resources dedicated to space could address pressing issues on Earth. Imagine if a portion of the space budget was allocated to mitigating climate change or funding global education initiatives. Redirecting even a fraction of the $50 billion spent annually on space endeavors might create significant improvements in quality of life, particularly in underdeveloped regions. This dilemma forces us to confront tough, ethical questions about prioritizing exploration over immediate human welfare. Rocket launches contribute to atmospheric pollution and greenhouse gas emissions, impacting Earth's environment. Each launch of a Falcon Heavy, for example, emits roughly 400 tons of carbon dioxide. The water vapor released at high altitudes traps heat, further compounding global warming. A surge in launches could shift atmospheric chemistry, exacerbating the climate crisis and heightening our responsibility to consider sustainable alternatives. With thousands of satellites already in orbit, Earth's lower atmosphere is becoming cluttered. Orbital congestion raises the specter of the Kessler syndrome, a scenario where collisions generate an unmanageable debris cloud. This debris could disrupt global communications and make future missions exceedingly dangerous. Developing space debris cleanup technologies is essential, yet they are costly and complex, emphasizing the need for international cooperation and regulation. Sending probes and rovers to planets like Mars or moons like Europa holds the risk of contaminating alien ecosystems. Even the smallest microbes from Earth could disrupt potential extraterrestrial life, rendering these ecosystems scientifically invaluable but environmentally compromised. Furthermore, if extraterrestrial samples brought to Earth contain unknown pathogens, they could pose unprecedented biosecurity threats. The ethical and scientific value of planetary protection cannot be overstated. Cosmic radiation is one of the most significant threats to astronaut health, especially for long-term missions to Mars or beyond. With no magnetic field or atmosphere to shield them, astronauts face radiation levels far exceeding safe limits, increasing their cancer risks. Shielding technology remains in its infancy, and new materials or methods are urgently needed to protect crew members, complicating mission designs and budgets. Microgravity takes a toll on human physiology. Astronauts aboard the ISS experience muscle atrophy and significant bone density loss, despite daily exercise. New studies also reveal effects on vision, fluid distribution, and even immune function. For long-duration missions, such as a Mars expedition, the cumulative physical toll is unknown, raising questions about the feasibility and safety of such missions. Long-duration missions isolate astronauts from their families and Earth, leading to heightened stress, loneliness, and mental health issues. The lack of real-time communication on a Mars mission, for instance, could intensify these effects, impacting teamwork and decision-making. To address this, researchers are exploring virtual reality tools and psychological support, but no current solution fully mitigates the mental strain astronauts endure. Spacecraft are intricate systems with numerous interdependent parts. Even minor malfunctions, like those seen on Apollo 13, can endanger lives and mission success. Fail-safe mechanisms are costly and challenging to perfect, especially as we venture farther into space where support is limited. The complexity and vulnerability of these systems require rigorous testing, which adds further financial strain. Space is filled with threats, such as solar flares and micrometeoroids that can damage spacecraft or harm astronauts. Solar flares emit bursts of radiation that could be deadly if astronauts are exposed. These unpredictable space hazards underscore the need for robust protective systems and continuous monitoring, further complicating mission planning. The vast distances involved in space travel make real-time communication and navigation nearly impossible. A delay of 24 minutes for signals to travel between Earth and Mars impedes decision-making and requires sophisticated autonomous systems. While AI holds promise, current technology is not yet fully capable of self-diagnosis and repair, making missions to distant planets especially risky. The race for space resources raises concerns about repeating Earth's history of colonial exploitation. Private corporations eyeing asteroid mining could monopolize space resources, creating a wealth disparity in a new frontier. The absence of international regulations to govern extraterrestrial resource claims could lead to exploitation and environmental damage, reminiscent of Earth's past. If we encounter extraterrestrial life, ethical dilemmas will arise. How should we interact with alien ecosystems? Should they be protected, or can we study them freely? These moral questions challenge humanity's principles, urging us to consider a cautious approach that respects potential alien life as we advance scientific knowledge. Astronauts embarking on deep space missions face extreme risks to life and health. As missions grow riskier, society holds a responsibility to protect their well-being. This duty of care becomes even more complex as private companies lead missions, demanding new ethical frameworks to ensure the safety and welfare of those venturing into space. The militarization of space threatens global stability as nations vie for dominance in this new domain. Satellites now serve as tools for surveillance and early warning systems, and several countries are investing in space defense. The risk of weaponizing space could lead to escalated tensions, turning exploration into a new arena of conflict. As nations and corporations lay claim to space resources, economic disparities may worsen. Without clear international laws, powerful nations could monopolize space wealth, leaving others behind. This could fuel conflicts over access to resources and deepen global inequalities, transforming space into a battleground for economic power. Many of the benefits of space exploration, such as advanced satellite data, are not accessible to developing nations, creating a technological divide. As affluent nations invest in space-based resources and technology, less wealthy countries may fall further behind, unable to benefit from humanity's progress in space, which further reinforces global inequality. Space exploration relies on public support, which can be fickle. High-profile failures or unexciting results can lead to public disillusionment, affecting funding and interest. This decline in support could stifle STEM fields as students lose motivation, impacting the next generation of scientists and engineers crucial for future exploration. Space exploration challenges our perception of Earth and humanity's role in the universe. While some view it as humanity's destiny to explore, others worry it may foster detachment from Earth's pressing issues. Balancing our pursuit of space with our responsibilities to Earth is essential to ensure we remain committed to environmental and social issues at home. Popular media often romanticizes space exploration, fueling public excitement, but sometimes leading to unrealistic expectations. Balancing these narratives with realism helps build sustainable support for space programs, fostering a society that values discovery while remaining grounded in the practical and ethical challenges involved. Space exploration represents a unique paradox, offering unparalleled opportunities alongside serious challenges. The path forward must be approached with caution, balancing our ambition with a commitment to ethics, environmental sustainability, and responsible resource management. As we pursue the stars, it's essential to ensure that our advances in space exploration ultimately serve humanity, enriching our understanding of the cosmos while preserving life and stability on Earth. Thank you for watching. If you liked the video, don't forget to give it a thumbs up and subscribe for more space insights.